shaft design.
So ito ang ating naging findings for basic. Now, so this can be applied sa problem na ating kahapon. Tingnan natin problem na yun.
Okay, so let us have now the design of the shaft. Okay, so how do we design the shaft? Okay, so when we say shaft, it's a rotating member which is a transmitting power. Okay, so this could be of different types. We have what we call the main shaft, which is of course driven by a prime mover. Meron din naman tayong tinatawag na line shaft or the secondary shaft. So, ano siya, parang way lang siya from prime mover to the other member. Okay? And then the last one, we have what we call spindles. Ito naman yung maliliit na siya, which are usually common do sa mga toys natin. Okay? So, yan. Yes, Claudine?
Ma'am, good afternoon po. Ma'am, pasensya na po pero medyo mahina po yung dating niya sa amin po.
Bakit kaya? Wait lang. 100% naman. Okay, anyway. Okay. Pakinig na. Hello.
Medyo mahina pa rin po, ma'am.
Parang last na yun. Hello. Pakiano na lang kung okay na, ha?
Opo, medyo rinig na.
Yan po, ma'am. Okay na po.
Okay. So, for today, we'll have the shaft design. Okay? So, when we say shaft, it is simply a rotating member which transmits power. Okay? So, we have different classifications of the shaft. We have the main power transmitting shaft. Okay? So, it is driven, of course, by a prime mover. Okay? And then we have also yung tinatawag natin na intermediate shaft, which is between the line shaft and the driven machine. Okay? And then the last one is yung short shafts, which we call spindles. So, kalimitan naman ito, makikita natin doon sa mga toys natin. Okay? So, yung maliliit doon na shaft, they are called the spindles. Okay? So, when we have the shaft design, okay, we will be basing our design on these two. Okay? Ang una is called based on the loading. And then pangalawa naman po is based on code. Okay? So, ganito po natin i-design yung ating shaft base sa dalawa pong ito. Okay? So, unahin po natin yung based on loading and then followed by based on code. So, ano po yung pinagkaiba ng dalawa? When we say based on the loading, we are to consider those loads that are applied doon sa shaft. Okay? So, is it your torsion, your bending, or it's combined? Okay? Kapag sinabi naman po na based on the code, okay, there is what we call ASME code and PSME code, wherein they have really the design procedure wherein you need really to follow para mo makompute yung mga dimension nung atin na shaft. So when we say we decide the shaft, we are after the diameter of the shaft to be used. Okay? So shaft is of course circular in cross-section, and then nagvavary lang siya whether it is a solid one or a hollow. Okay? So solid or hollow shaft. So based on the loading, so ito muna po yung ating kukunin. Okay? So based on loading, we have the first one. We say torsion, pure torsion. The shaft is under pure torsion. Second one, we have their pure bending. And the third one would be combined. Okay, so meaning you combine the two. There is torsion, there is bending also. Okay, so ito muna po bago ito ng dalawa. Okay, so kumbaga, if you are to compare the two, okay, it would be easier to design the shaft based on the code. Okay, kasi nga, meron na talaga siya na procedure na if-follow mo lang for you to come up with the dimensions of the shaft. Naririnig pa ba? Hello?
Yes po, ma'am.
Okay
Yes,
naman?
ma'am.
Rinig po.
Okay.
Okay po.
Okay, so let us have shaft under pure torsion. Okay, so you look at this illustration. Okay, so this slender member would be the representation of your shaft. Okay, and then you have here yung dalawang dulo po na yon, yung rectangular with an X. Okay, that refers to the bearings of the shaft. Okay, so yun po yung bearings of shaft. This long straight member would be the shaft itself. And then here, yung arrow po na yun would refer to the torsion. Okay? So, in this case, this is the representation of a shaft under pure torsion. Okay? So, how do you know that there is a pure torsion? It's a shaft po natin. If you do not see any gear or pulley loaded to the shaft, and at the same time, you have the power transmitted. Okay, yung power transmitted po na yan, doon po natin makukuha yung value nitong torque na to. Okay, so we recall yung mga power formula po natin, okay, when we have yung machine members under pure torsion. Pakibalikan nyo na lang po ulit yun. Okay, so one of those equations for power equal to Tn over 63025. Okay, so from there you can compute for the torque, that is simply 63025 multiplied by the power divided by n. Okay, you have to uh, follow lang po that yung power po dito should be in horsepower and yung n dito should be in RPM for you to arrive at torque in unit pound inch. Okay, so yan po yung kalimitan natin ginagamit if we are solving on the English unit, okay, to obtain the value of this torque. Okay, so how do we design the shaft, okay, under pure torsion? So, ang ginagawa po natin, katulad po noon sa members under pure torsion, wherein, ano po yan, we base our design on the strict failure and another one on the deformation failure. Okay? So, the induced stress, okay, of the shaft, when it is subjected to pure torsion, it's called the torsional shear stress. And this is the equation for your torsional shear stress. Tau equal to Tc divided by J. Okay, so yung tau po, that would be our torsional shear stress. T pertains to the torque, which is obtained, of course, from the power transmitted. C, ano po yung C na yun? We call this your radial distance. Okay? So, alin po yung radial distance? Halimbawa po, ito po yung atin na shaft, solid shaft. Okay? This is its diameter, D. Okay? So, pag sinabi po natin radial distance, it would always be measured from the center. Okay? So, this is the center. So, any distance from the center is called C. It's a radial distance. So, you call this C. Okay? From center hanggang dito po sa point na yan, that would be C. But we are after what we call C maximum. What is the maximum radial distance? Yan po ang kukunin natin. We get the maximum radial distance for us to arrive at the maximum torsional shear stress. Okay? So, pag kinuha po natin yung maximum radial distance, again, measured from the center up to the outermost fiber. Okay, so ito po yun. And this value would be your C maximum equal to the radius. Okay, and when we say the radius, that would be the diameter divided by 2. Okay, so that would be the C maximum. Okay, that is if we have a solid shaft. Okay, yun po yung radial distance C. What about yung J? When we say J, you call this the polar moment of inertia. Okay, and for solid, okay, J for solid is simply pi d to the fourth divided by 32. Okay, and if it is hollow naman po, it would be pi quantity d to the fourth minus d to the fourth, okay, divided by 32. The big letter D pertains to the outside diameter, whereas small letter d pertains to the inside diameter. Okay? So, iyan po yun. Okay? So, when we are to derive po the short shear stress for a solid shaft, so we start with the general equation Tc divided by J. Okay? For value ng C, ang gagamitin po natin itong C maximum po. Okay? And for value ng J, so kukunin po natin yung J para sa solid. So, yun po yung atin na isa-substitute. Okay? So, we start with the general equation tau equal to Tc divided by J. Okay? So, ang gagamitin po natin would be J for solid. So, T, C maximum would be D over 2. Ito po yun. Okay? And then J, you have their pi d to the fourth divided 32 for solid. Okay? So, having that, okay, so T, you have their D over 2 divided by pi d to the fourth divided by 32. So you can cancel out d and d to the fourth. We leave here d cubed. Okay? 2 and 32 can be cancelled also. That leaves 16 dito po. So simplifying that, will arrive at 16t over pi d cubed for your tau. Okay? So this would be tau for a solid shaft. Okay? So this is the induced stress of your solid shaft. And what we do in design is that we equate this one po to your design stress tau d. Okay? So for a good design, you then equate that to, okay, the induced stress to the design stress. This design stress, this can be tau u over fs, o kaya naman po pwede din tau y over fs. Okay, so this can be tau u divided factor of safety, or it can also be tau y divided by factor of safety dependent upon the basis of design. Okay? Or kung hindi naman po binigay ang basis ng design, pwede rin po yung type ng material. If ductile, you use tau y. If brittle, you use tau u. Okay? Now, this tau y and tau u, they will come from the values of your sigma u and sigma y. So, we recall, ano nga po ba yung value ng tau u? Hello? Ano po nga ba yung value ng tau u? Hello? Anyone? Naririnig po? Hello? Naririnig po ba?
Yes po. Ang
So what is the
imamultiply,
value of tau u?
imamultiply po siya sa 0.75 ng sigma u.
Okay, correct. Okay. So, tau u is equal to 0.75 sigma u. Tama po si Char. And your tau y would be equal to 0.6 of sigma y. Okay. So, i-recall lang po lagi natin yan. Again, this is the induced stress of your solid shaft. Okay. To be equated to your design stress. And what is the equation? 16t over pi d cubed. Okay. Now, let us go naman po if we have a hollow shaft. Okay? So, kapag hollow shaft naman po yan, say big letter D for the outside diameter, and then sa inside diameter D naman po, okay, we use small letter D for the inside diameter. Okay? Now, ang kailangan po ulit natin is yung C. Okay? Radial distance. So, measured from the center, kukunin po natin yung C maximum, yung pinakamalayo, okay, from the center. So, alin po yung pinakamalayo sa center? So, this would be the distance, okay? And this would be your C maximum, okay? So, this C maximum would be equal to your outer radius, okay? This is the inner radius, hanggang dito lang, okay? Hanggang dito will be the outer radius, okay? So, we use big letter R for the outer radius. And that would mean the outer diameter divided by 2. Okay? That gives you your value ng C maximum. And to recall, yun naman pong J for hollow, we have this. Okay? Pi quantity d to the fourth minus d to the fourth divided by 32. So, yun po yung isa-substitute natin dito. Okay? Tau equal to Tc divided by J. Okay? So, T, C would be D divided by 2. And then this would be the value of J. Okay? So with this po, ang pwede lang po natin na i-cancel out would be 2 and 32. You'll have your 16. Okay? Yung D po, hindi po natin siya pwede na i-cancel out. Okay? So that gives us po 16TD over pi, okay, D to the fourth minus D to the fourth. Okay? So this would be our tau for the hollow shaft. And then kung gagawin natin dyan, this tau would be equated to your tau or your design stress for you to obtain the value of D, okay, the outer diameter and the inner diameter, small letter d. Okay? Now, ano lang po ang i-introduce natin ngayon dito? We have what we call diameter ratio K. Okay? Diameter ratio that is defined by yung K equal to D over D. Okay? This is of course ginagamit kapag po siya ay hollow shaft. Okay? Again, small letter D would be inner diameter and then big letter D would be outer diameter. Okay? And the ratio between the two would be the value of K, D over D. So, isasama po natin siya dito sa equation ng hollow shaft. Okay? So, 16TD, di ba ito yung nakuha natin kanina? 16TD over pi, quantity D to the fourth minus D to the fourth. Okay? So, ito din po yun. Okay? Ere po yun. Ano na po yung ginawa natin? You look at yung ilalim po, yung denominator, we multiply that by D to the fourth over D to the fourth. Okay? This is the outer diameter. Okay? Yan, to the fourth over D to the fourth. And this value, okay, this is just equal to 1. Ibig sabihin, even if we multiply this, okay, factor dito sa buong ito, it will not affect the value since the value is equal to 1. Okay, so any value multiplied by 1 will be the same value po. Okay, or any number multiplied by 1 will be the same number. Okay, so kung minultiply po siya natin dito ng d to the fourth over d to the fourth, okay, parehas lang din po yung kanyang value. Mag-change lang po siya ng form. Okay, and then what we will do po is to distribute po ito dito sa nasa parenthesis natin. So, you multiply it doon po sa nasa loob na yon, same thing dito po. Okay? Now, so what would happen? You have your 16TD pa rin, yung numerator. And then you have their pi. Ito po, pang multiply natin to d to the fourth will yield d to the 8 divided by d to the fourth. Okay? And then minus small letter d to the fourth multiplied by big letter d to the fourth divide d to the fourth. Okay? So, ayan. So, dinistribute po natin, minultiply po natin sa every term. Okay? And then, tingnan po natin ito at saka iyon. Okay? What is common between these two terms? Okay? Ang common po is d to the fourth. Kaya inilabas po natin siya nung parenthesis. Okay? So, naging ano na lang po dito, that will be pi d to the fourth. So, what is left here? This is d to the 8. Binawasan po natin ng 4. So, we have there d to the 4th divided by d to the 4th. Dito naman po, sa pangalawang term, ito po yung nilabas natin. So, ang matitira is small letter d raised to the 4th over big letter d to the 4th. Okay? And we look at this one po. d to the 4th minus d to the 4th, that is equivalent to 1. Okay? And this factor here po, small letter d over d, that is your value of k. Okay? So that is why that is equivalent to k raised to the 4th. Okay? So, having here po, okay, pwede po natin i-hiwalay itong factor na to. Okay? So this will become 16t, okay? This is d to the 4th pala, nakalimutan ko. Ito po, maka-cancel out po yung dalawa. Matitira doon is d cube. So, ito po mawawala na po dito. Okay? So, ano po yung matitira? That will be 16t divided by pi d cube. Times, ari po ihihiwalay po natin, 1 over 1 minus k to the 4th. Okay? So, this would be the resulting equation for your tau of hollow. Okay, 16t over pi d cube times this factor. And if you are to look at this po, okay, ito po yung ating tau for solid. Okay, yan po yung equation ng tau ng solid. Just multiply it by this one, 1 over 1 minus k to the 4th, which is your hollow factor. Okay, so ibig sabihin, your tau for hollow would be equal to what? Tau of solid times the hollow factor 1 over 1 minus k to the fourth. Okay? And you recall tau of solid would be equal to 16t over pi the cube times you have there the hollow factor equal to your tau h at yun po yung equate natin to the design stress. Okay? So, this would be po yung magiging equation natin. So, iisa na lang po yung equation natin. Kapag po siya solid, so aansin mo po itong hollow factor. Kapag po siya hollow, so you need to include. Okay? Hello? Nasundan po ba?
Yes po, ma'am.
Okay? Question? Wala naman.
Wala pa naman po.
Okay, so that is how you decide the shaft based on the strength failure. Okay? So based on the deformation man po, okay? So the deformation is called the angular deformation, or we can call this simply as angle of twist. Okay? So tinatawag din po siya as angle of twist. Okay? So when you subject the shaft into a torsional moment or torque, ang nangyayari, nagkakaroon siya ng angular deformation. Okay? And this angle is measured through the equation theta equal to TL over JG. Again, if you use this, the angle that you'll obtain will be in radians. Okay? It will be in radians. Okay, so ang gagawin po natin, isa-substitute lang po ulit yung value ng J kapag solid at kapag hollow. Okay? So J, kapag po theta ng solid, it would be T times L over J is pi d to the fourth over 32 times yung G. G is the modulus of rigidity, okay, or simply the shear modulus. L pertains to the original length, okay, and T again would be the torsion or torque, okay, torsional moment. So from this, yes po. Hello?
There are three parts that is
May question ba? May question?
Pindot lang po yata, ma'am.
Okay. Kala ko kasi may nag-raise ka ng hand. Hindi ko lang naabot kung sino. Okay. So, simplifying this would be 32 TL over pi d to the fourth G. Okay? Yan po kapag po siya ay solid. So, kapag po hollow, ano po ulit ang gagawin natin? Kanina, may introduce na tayo na hollow factor. Okay? So, kapag hollow yan, ang gagawin natin, theta of hollow would be theta of solid multiplied by the hollow factor 1 over 1 minus k to the fourth. Okay? So, ganun lang po ang ating laging tatandaan. If hollow, multiply it by the hollow factor. So, this would be equal to 32 TL over pi d to the fourth G times 1 over 1 minus k to the fourth equal to theta ng hollow. Okay? Dito po makikita natin, dinerive din siya from J for hollow. Okay? Considering ang papalitan ng J ng hollow. Okay? And it would arrive at this state, this equation po. Parehas lang din po ang lalabas. Okay? So, this theta, this angular deformation po, ang gagawin po natin dyan, we are to simply equate those to what we call theta limit. Okay, so for a good design, anong gagawin po natin? Your theta, okay, angle of twist is to be equated to the allowable limit of deformation. It can be theta of yung solid or theta kung hollow po yung ginamit, equal to yung allowable limit of deformation. Okay? So, if this is not given, of course, so wala po tayo based on the strength failure, on the deformation failure. Okay? So, dalawa po yung makukuha natin sa sagot. Isa galing doon sa strength, isa galing dito sa deformation. Okay? Whichever is higher, then that would be chosen. Okay? So, yun po yung pagde-design base kung ang atin pong shaft is under pure torsion. Question? Hello?
And so far po, ma'am.
Okay, so kung natandaan niyo po yung ating members under pure torsion, basically the same lang po dito. Okay? Ang inad lang po natin is yung diameter ratio, okay? And we introduce the hollow factor. Okay? Yun lang po yung pinagkaiba. Okay, mamaya po yung sample problems natin. Idiretso ko muna dito sa peer bending. Okay. So let us have naman po if the shaft is under peer bending. So katulad naman po ito doon sa members under peer bending. Lamang, we are now limited doon sa cross-section po. Okay? So same thing po. Okay? Kapag peer bending, deflectional stress would be our induced stress. Okay? So this is our general equation. Deflectional stress, sigma sub F equal to mc over I. Okay? Again, M pertains to the maximum moment. C would be the perpendicular distance from neutral axis to outermost, and I would be the moment of inertia. Okay? So again, C and I, okay, this will come from the beam cross-section. And yung M po naman will come from the beam loading or the load diagram. Okay? Ngayon lang, yung ating pong beam would be yung shaft. Okay? Yung shaft po natin will serve as the beam. Okay? So, yun po yung mangyayari ngayon. So, this one po, for the cross-section, doon pong kinuha natin yung peer bending, we use different cross-sections. Okay? We have the regular cross-section at meron din na economic sections, kung natatandaan ninyo. Okay? Dito po ngayon, sa shaft under peer bending, we will be restricted to only one cross-section, and that would be circular. Okay? So, circular lang po ang gagamitin natin since it is a shaft. Okay? And for the circular shaft, mag-vary lang po siya if it is solid o kaya po ay hollow. Okay? So, nakalimit po tayo doon sa C at saka sa I. Okay? So, for solid circular shaft, okay, so circular, ano po ang value ng atin na C? Okay? Kapag po siya ay solid, having here diameter D, your C would be equal to, anong gagawin natin? Have first the neutral axis, and then from the neutral axis, kukunin natin yung distance pataas at saka distance pababa. Okay? Kung alin po yung mas mataas, yun po ang i-consider natin. Okay? So for circular solid cross-section, your C would be D over 2. Okay? And what about the value of I? Okay? I would be pi d to the 4th divided by 64. Okay? Kapag hollow naman po, ito naman po yung hollow. So, have the neutral axis. This is NA. Yan, this is NA. O, kukunin ulit. Distance pataas, tsaka yung distance hanggang doon sa baba. Whichever is higher, then that would be the value of C. Okay? So, here, C would be the outside radius. So, D over 2. Okay? So, that would be D divided by 2. And I value would be pi quantity d to the 4th minus d to the 4th divided by 64. This is for half. Yan. Yan. So these are the values of C and I. So naka-fix na po yan if we are doing the shaft design. Okay? Kasi hindi naman tayo mag-vary ng ibang cross-section. We are restricted to a circular cross-section. Ang variation lang, it's either solid o kaya po ay hollow. Okay? So, ari po yung circular and then solid at the same time. Ito po yung hollow. Okay? So, C and I values are this one. Okay? So, having that as yung C and I, isa-substitute po natin dito sa equation natin na flexural stress equal to MC over I. Okay? So, you have there M. This is yung C. D over 2. And ito po yung I, pi d to the 4th divided by 64. Okay? So, i-rewrite ko lang po dito. M, C is D over 2, and then I is pi d to the 4th divide 64. Okay? So, we can cancel out D and D to the 4th. We'll have here D cubed. 2 and 64 will have here 32. So, simplifying this, we arrive at 32M over pi d cubed. BQ. Okay? So this would be the flexural stress if it is a solid shaft. Okay? At ano po yung gagawin natin? Yan po yung equate natin to your design stress, sigma T. Okay? Notice that we use here for the design stress sigma. Bakit po sigma? Kasi sigma yung induced stress. And this design stress, it can be sigma U over Fs, o kaya po ay sigma Y over factor of safety. Okay? Yan. And kapag hollow naman po, So kapag hollow naman po, ito naman po yung substitute natin na value ng C at I. So again, we start with the general equation, MC divided by I. Okay? So yun yung M. Ang C po ay D over 2, katulad niyan. And this is the value of I, katulad po nito. Okay? So, what can we cancel here is simply po yung 2 and 64 lang din po. Okay? So, it will arrive at 32. And knowing that this is hollow, pwede na po ulit natin gamitin dito yung ating analysis kanina and isama natin yung hollow factor. Okay? So, since ito po yung nakuha natin para sa solid, okay, ito po yung solid, so we know theta or sigma of yung flexural stress for hollow would be that of solid, okay, multiplied by the hollow factor 1 over 1 minus k to the 4th. Okay? And from that, this would be 32m over pi d cubed times 1 over 1 minus k to the 4th equal to the flexural stress for a hollow shaft. Okay? So, iyan din po yun. To be equated to your design stress. Okay? So, yun yung equate natin sa design stress for us to obtain the value of the diameter. Okay? So, yun lang po ang tatandaan natin. It would be the solid, okay? The stress for the solid then multiplied by the hollow factor. So, aalsin po ito kapag solid, kapag po hollow, idadagdag. So, same equation lang. Okay? Ano lang po yung bago dito? Okay, yung M po natin is again the maximum moment. So, how do we obtain the maximum moment po doon? Halimbawa po, ito yung illustration natin. This is po yung atin na shaft. Again, the long straight member here pertains to your shaft. And look at this one, okay? There is a gear or a pulley loaded to it. So, that is an indicator. Kung nakita mo po yung shaft, may pulley na nakakamit sa kanya or may gear na nakakamit sa kanya, yun po ang indicator na meron tayong bending load. Okay? So, may bending load po tayo. Okay? So, this bending load, okay, that is caused by the gear or the pulley. So, we represent that as FB. Okay? And then here are your bearings. On the bearings are the supports. So the reactions and loop of supports would be RA and RC in this case. Okay? So nasan po yun? Doon sa bearings. So this RA, FB, and RC, this will be the bending loads on the shaft. Okay? So yan yung gagawan ngayon natin ng shear and moment diagram. Okay? So from this, you create a shear and moment diagram. Okay? And galing sa shear and moment diagram, dun po natin makukuha yung maximum moment. Nakuha po ba? Okay? Kung wala naman po, kung ito naman po, okay, kung marirecall po ninyo, meron po tayong table 82. Okay? So, sa table 82 po, meron po doon mga equations ng maximum moment. Okay? So, pwede po natin gamitin yung mga equations po na yun ng maximum moment kung may kaparehas po na katulad nito. Okay? So, in that case, hindi mo na po kailangan gumawa pa ng shear and moment diagram. Okay? Nasundan po ba? Hello?
Yes po, ma'am.
Okay? Now, ito lang po yung isa ko pang i-emphasize dito. How do you obtain the bending load? Okay, so sabi ko nga po, paano natin malalaman ng bending? Kapag po may gear or pulley na nakaload doon. Okay, so you have to to determine the bending load doon sa gear or doon sa pulley. So, paano po natin makukuha yung bending load FB na to? Okay? So, i-recall po natin kanina, sabi natin, there is a power transmitted. Okay? So, yung power transmitted, from power, makakasolve po tayo ng torque. Tama po ba? Yung equation natin kanina. Okay, so from the power formula, makakakuha ka po ng torque. Okay, and then you recall, this torque is equal to force multiplied by the radius. Yung F po na to would be the bending load. Yan po yung magiging bending load mo. At yung R po na yan would be the radius of the gear or the radius of the pulley. Okay? So from this equation po, dyan po tayo makakasolve ng bending load. So what would be the bending load? It would be the torque divided by the radius of the gear or the pulley. Okay? So ito po yung magiging value dito. Okay? Maggagaling din po yun doon sa power transmitted. Okay? So doon po yun po. Question? Hello? Wala?
Wala naman po, ma'am.
Okay, so let us have muna po yung sample problems natin sa pure torsion at pure bending before po natin pagsamahin yung dalawang loads na yun. Okay, so let us have here sample problems 1 and 2. Yung 1 po, yan po yung para sa pure torsion. Okay, at yung 2 po, ito po yung para sa pure bending. Okay, so I'll give you first na lang po muna dito yung way kung paano mo siya i-solve. Okay? And then you work on it po. Okay? And then I'll post po a Jamboard for your solution. Okay? But then I'll tell you first kung paano po siya gagawin. Okay? So let us have the first one. Again, this is on pure torsion. A cold finish shaft 1045 ASI is to transmit power of 350 HP at the speed of 700 RPM. For a K equal to 0.7, you compute for the shaft diameter. Okay, so let us have first the given values. Okay, so you are given here the power, which is 350 HP. Okay, and then you have here the speed. We designate that as N equal to 700 RPM. Okay, and also a diameter ratio K equal to 0.7. If you are given a diameter ratio, that would mean po that the shaft is hollow. Okay? Otherwise, kung wala pong binigay, sabihin, it is a solid shaft. Okay? So these are the given values. Next would be the material specification. Okay? So just look at AISIC 1045 cold finish. Okay? So cold finish, then determine what would be the value of sigma u and what is the value of your sigma y. Okay? So for the factor of safety, so you may use here table 1.1. Okay? So alam mo naman po kung paano gamitin yun. And then for the design stress, okay? So sa design stress, ano po ba yung gagamitin natin dito? Are we to use sigma d or tau d? Alin po ang gagamitin natin? Yung po bang sigma d o yung tau d?
Tao di po.
O, tau d. Bakit po tau d? Kasi this is under pure torsion. Okay? And torsion is in form of tau. Okay? So your design stress would be equal to tau d, which is equal to tau y over fs. Why do I use here tau y divide factor of safety? Since this is a ductile material. Okay? And the basis of design is not mentioned. Okay? Kaya tau y over fs po ang ginamit. Okay? So for tau y, it will come from the value of your sigma y, 0.6 of your sigma y. And then after the design stress, you then equate for a good design, okay? Equate design stress to the induced stress. Okay? This would be tau of the hollow shaft. And what is the tau of the hollow shaft? 16 t over pi d cubed times 1 over 1 minus k to the 4th. Okay? Equal to your tau. Okay? Ano po yung wala dyan? We are looking for the diameter. K is already given, equal to 0.7. So you simply look for the value of t. Okay? Saan po natin makukuha yung value ng t? It will come from the power. Okay? Power equal to Tn over 63025. Doon mo po kukunin ang value ng torque. Okay? Yan. Make sure power is in HP and this end value is in RPM to obtain your torque in pound-inch. Okay? Tapos, pag parehasin na lang po yung unit, it should be in kip-inch para po maging uniform po siya dito sa sigma U at saka sa sigma Y. Okay? So, ang makukuha po natin dyan would be the diameter, the outside diameter specifically, big letter D. Okay? Pag nakuha na po yung outside diameter, then you solve for the inside diameter. Okay? Using naman po yung relation ng K, diameter ratio K equal to 0.7. Okay? Nasundan? Hello? Nasundan po ba kung paano yung gagawin?
Yes po.
O the others po. Yun naman po iba. Gising pa ba?
Yes po.
Yes, Jeric. Would that mean a yes, Jeric? Okay, so para diretso na yung pagsusolve nyo, okay, let us have naman po yung problem 2. Okay, yung problem 2 naman, this is under pure bending. Okay, so let us have number 2. A shaft with K equal to 0.9 made of AISI C1045 as row. Transmit 60 kilowatt power at 1350 RPM. Okay, shaft is loaded with 12-inch spar gear located mid-span of the total length of 36 inches. Consider static load and bending effect only. Compute the required diameter. Okay, so ito po, okay, this is your spar gear. Okay, so this is the spar gear that contributes to your bending load. Okay, so ito po yung bending load natin. Say we call it FB. Okay, so this would be the bending load FB. So ito po yung indicator natin. May gear na nakalagay sa kanya. So ibig sabihin, there is bending. And then you look at this one. It transmits 60 kilowatt of power. And we all know if there is power, then there is corresponding torque. So masasabi natin, may torsion po yan. Okay? Tapos dito po, meron pong gear. So may bending yan. So it would be a combined torsion and bending. Okay? But then, because of this statement, consider static load and bending effect only. So, ibig sabihin, you will be neglecting the torsional effect. Okay? So, kasi kung isipin natin yan, it would be a combination of the two. Kasi may power po doon, so may torsion. Okay? Tapos, ito may gear, so may bending. Okay? So, combined siya. But then, because of this statement, consider bending effect only, then, assume natin yung torsional effect ay hindi kasama. Okay? So, it will result to pure bending only. Okay? Now, meron po tayo dito na bearings at A and C. So, we have the corresponding reactions R at A, reaction at A, and reaction at C. Okay? And then you have here the length. This is 36 inches. The one, ito naman, is located mid-span. So, half of it would be 18 inches. Okay, nandun po yung spar gear. Okay, so let us have the given. We have the K equal to 0.9. Power is 60 kilowatts. What you need to do is to convert this into HP. Okay, know the conversion place. So 60 kilowatt to be converted into HP. And then speed is 1350 RPM. You have here diameter, 12 inches spar gear. So that's diameter of the gear, okay, B, equal to 12 inches. Okay, and located mid-span for a total length of, okay, total length equal to 36 inches. Okay, those are the given values. Material. AISI C1045 as row. So find value of sigma U, sigma Y. Okay? Factor of safety. So pakihanap po ulit sa table 1.1. And then we'll have the design stress. So this time, this is under pure bending. So yung design stress po natin would be sigma D. Okay? Sigma D equal to sigma Y divided by factor of safety. I use your sigma Y again. This is a ductile material. Okay? And then after the design stress, again, you equate for a good design, equate design stress, sigma D to the induced stress of material. Okay? That would be flexural stress of a hollow shaft. And what would be its equation? 32M over pi d cubed multiplied by the hollow factor, 1 over 1 minus k to the fourth. Okay? Yan. So that would be our working equation. K is given. Your sigma D is solved here. Okay? Yung D na ito po, yun po yung hinahanap natin. That is the unknown. So we need to find value of M. Again, M is the maximum moment. Okay? So how do you obtain the maximum moment here? Okay? You use shear and moment diagram o kaya naman po, kung may kaparehas po ito dun sa table 82, so yun po yung kuhanin natin equation. Okay? Equation ng M. Just make sure you solve for the value of this FB. Okay? So, saan po manggagaling yung FB? Again, this FB, masosolve po natin if we have the torque divided by the radius of the gear. Okay? The RB. Okay? So, you're given here 12 inches. So, half of that, that would be 6 inches. Yung torque naman po, masosolve coming from the transmitted power na 60 kilowatts. Okay? So, once you know the value of this FB, yan, magkakaroon ka na po ng shear and moment diagram. Gagawin mo na po yun. Okay? O kaya naman, sabi ko nga, you may use table 82 para po masolve yung maximum moment. Kung may katulad po doon. Naintindihan po ba? Hello?
Yes po, ma'am.
Okay, good. So, hindi lang po natatapos dun sa diameter na to. Yung po kailangan din po natin yung inside diameter. Okay? Kailangan din po yung inside diameter. So, you need to consider po yung atin na diameter ratio K. Okay? So, you take a screenshot of this sample problem to aid you in solving it. Okay? So, paki-screenshot na po para magpalit po ako ng presentation. Okay? Yun naman pong Jamboard yung ilalagay ko para you can po paste your answers there po. Okay? So, screenshot lang po kare para po maging guide nyo para ma-solve nyo po ng maayos. Paki-inform na lang po ako kung okay na.
Okay na po, ma'am.
Okay na? So, the others, yan ha, paki-screenshot tapos ano ka na po ito. I'll stop the presentation, okay, and then I'll send you the link for the Jamboard. So, paki-solve nyo muna po.
1.65 pounds per kg and in kilogram, that's 1,025 kilogram per every load. Equal to the mass total. How do you get the volume? So, dapat ang ating mga volume ang ito ay mga nakaset in the area times the depth that is above the water line. Ito ang inuubog pag dumami pa. O in meters, in meters. How about the 36 meters? Okay, 0.36. So therefore, I'm going to be 2 by 5.36.
nangyari na? Wait lang ha. I'll replace ko lang yung yung access before I copy the link. Wait lang. So, you work on your solution. So, ilagay na lang po dyan sa ating manual. And then, mamaya, you take a screenshot of it para ma-post po natin for our discussion, of course. Nangyari.
Pardon has a 1,000. Maybe from that's the total. Ay ilang 75 kilogram na tao ito. Yan.
Wait lang po ha.
Equals the number of passengers. Therefore, it will be 1,407 divided by 75.
Okay. So, on our chat box is the link for the Jamboard. Okay. So, kindly join to our Jamboard. So, I'll wait for your answers here po.
ang variable natin. At dito na nakasabi natin
Okay, Miss Ashley. Hello.
Hello po.
Okay, explain your work for problem 1.
the lesser na height. So kaya, water
Ay, hindi mo po.
oil from the given mas mataas ang
Okay, Miss Ashley. Okay.
1,000
So, kanina po ay yung pong kagaya po ng nilist ni ma'am na given. So, sa power po ay may 350 HP po na given. Tapos, may binigay po na speed of 700 RPM. And meron pong K na 0.7. So, sa material specifications po, makikita po ang Sigma U at Sigma Y for AISI C1045 cold finished sa table 88 po, page 17. Doon po ay makikita po natin na ang value po na Sigma U for AISI C1045 ay 100 KSI. Tapos Sigma Y po ay 85 KSI. Tapos, as for the factor of safety po, makikita po natin ang value na sa page 1, table 1.1 po, which ang factor of safety po ay 2.
How do you come up with the value of 2? What are those designs? How do you come up with the value of 2? What are those design considerations?
Ang ginamit ko po doon ay based on yield strength po, tapos steel po, ductile po.
Okay.
Tapos, as for the design stress naman, since ang ginamit nga po natin sa factor of safety ay yield strength, so sa design stress po ay tau-D po. And na-discuss po kanina, tau-Y po. And na-discuss po natin kanina na kapag po kukuhanin po ang tau-Y, ay i-multiply po ang 0.6 sa nakuha pong value ng sigma y galing po sa table. And ayun po, i-equate po natin siya sa tau-D, kagaya po ng ating ginagawa, at makakakuha po tayo ng value na 25.5 KSI po. And then, following po doon sa pagkakadiscuss po niyo kanina, kukunin po muna natin ang value ng torque. And makukuha po natin yon by using the formula po na P equals T times N over 63025. So, substituting po our values, makakuha po tayo ng value ng torque na 31512.5 pound-inch po. And then, after po nun ay pwede na po tayong mag-proceed sa pag-equate po sa ating for a good design. So, tau-D equals tau hollow po. Tapos, yung pong formula ng for hollow ay i-equate po natin sa tau-D, which is yung 16T over pi d cube. Tapos, i-multiply po siya sa dun po sa 1 over 1 minus k raised to 4 po. Ayan po yung hollow factor. Kailangan po siyang i-multiply sa hollow factor. And then, substituting po ulit our values. Yung D po ay 2.023261952 inches po. And then, gagawin po natin siyang into standard size na 2.125 inches. And then, yun, para naman po dun sa smaller diameter po, ay nanggaling po yun sa diameter ratio po na K equals smaller diameter plus outer diameter po. And then from that, makakompute na po natin using that formula na ang value po ay 1.4875 inches and then gagawin pong standard size into 1.5 inches po.
Thanks, Miss Ashley. Okay, so this one is the standard size. This is equivalent to 2 and 1/8. Okay, that is the outer diameter, and the inner diameter would be 1.5 or 1.5 inch. Okay, so this is correct. Okay, so let us have now problem 2.
sa oil even 50C. Sa tubig naman, sa kabila, ang residual 1,000.
I have seen here once
From the
for
same
problem.
reference na pantay.
Ayan, okay.
So divide the
Again.
750 on what density we get. This is not or
Good
greater
afternoon po, ma'am.
Okay. Kindly explain your work, Ken. For problem 2.
For problem 2 po, the given po is K is equal to 0.9, P is equal to 60 kilowatts, N is equal to 1350 RPM. Diameter of spur gear is 12 inches, length po is 36 inches. For material specification po, AISI C1045 Astrol, Sigma U po is 96 KSI, Sigma Y is equal to 59 KSI, located at table 87, page 15 po. For factor of safety, since it is steel po and ductile, we will use factor of safety of 2, located at table 81.1, page 1. And then for a good design, sigma D is equal to sigma FH, where sigma D is equal to sigma Y over factor of safety, and sigma F is equal to 32 times moment over pi d cube times 1 over 1 minus k raised to 4. Since we don't have the value po for M, the, yung formula po ng MA, kinuha ko po sa page 3 po, where maximum moment is equal to FL over 4. Since wala pa po tayong value na
That is using table 82. Tama?
82 po. Since wala pa pong value ng force, hanapin po muna yung value ng force, where force is equal to T over radius. Since wala pa rin pong value ng T, hahanapin po muna yung T using T is equal to T times N over 63,025. And then, yung power po, i-convert po mula kilowatts papuntang HP. Kaya po 60 kilowatts times 1 HP over 0.746 kilowatts is equal to T times 1,350 RPM over 63025. Ang makuha pong value ng T ay 3754.840632 pound inches. Tapos mahanap na po natin ang force by dividing T over radius po, since ang spur gear po ay 12 inches, gagamitin po ay yung half po na 6. Kaya po 3754.840632 divided by 6 po is equal to 625.806,719 pounds. Yun na po yung force. Tapos since may force na po, mahanap na po yung moment using FL over 4 po. Then substituting po, ang moment po ay 5632.260947 pound inches. Tapos i-convert po sa tip inch, which is 5.632260947. Since kompleto na po yung values, pwede na pong i-substitute sa initial na formula po na sigma y over factor of safety is equal to 32m over pi d cube times 1 over 1 minus k raised to 4. Substituting the values po, we will get the diameter of 1.78159736 inches, and standard size po ay 1 over 1 and 7/8 inches. Then we will use po yung diameter ratio na K is equal to smaller diameter divided by yung bigger diameter po. And makakompute po ay 1 and 3/4 inches po in standard size.
Okay, thank you, Ken. Okay, so you have here our answer for problem 2. Okay, so this one again is under pure bending only. So we neglect the torsional effect. Although there's a given power here, okay, so ini-neglect po natin yung torsional effect niya. As stated here, you consider the bending effect only. Okay, the others. Do you yield the same answer po ba?
Yes po, ma'am. Same po.
So I am I am tallying your submissions on our mga ano natin, sa mga Jamboard natin. Okay, and I see it na yung mostly yung mga nag-a-answer din lang the same, but then yung iba talagang wala sinasubmit. Okay, so this is a way for you to interact doon sa klase natin. Okay, although this is online, yan, dapat po cooperate din po tayo by simply submitting your answers to our Jamboard. Okay? So, sana po yung iba ano na din, okay? Mag-submit din po nung inyo na mga work dyan, okay? Yung mga solutions nyo. Okay? Sabi ko nga po, these are all safe and I am tallying your submissions on this. Okay? Thank you. So, let us have now po. Okay, so yung iba, you may continue your work po and then post it here. And then, I'll have muna po another topic. Okay, so this time po, pagsasamahin na po natin yung dalawa. So this time, it's combined torsion and bending. So I'll end this presentation sa Jamboard, but then you can still submit po your work. Okay?
Dapat na ilipat kung one container, one another. Sabi natin, container runs using containers if they flow. So liquid flows. Gas flows. So, yan naman ang ating pag-usapan in the next part of the COVID-19. So, mas madami ito nangyayari
Okay. So this time naman po, okay, let us have a shaft under combined torsion and bending. Okay, so kanina po, pure torsion lang o kaya pure bending lang. Okay, ngayon po, pagsasamahin po natin. Naririnig po ba ako? Hello?
Yes po, ma'am.
Okay. So, i-recall muna po natin yung equation natin kanina. Okay? Kapag pure torsion, we yield a torsional shear stress. Okay? So, kapag po, yun dito na lang. Okay. So, kapag po we have here pure torsion, we come up with our torsional shear stress, tau, equal to 16T over pi d cubed times 1 over 1 minus k to the fourth. Okay, so this would be a general equation. If it is hollow, you include this, the hollow factor. If it is solid, aalsin ko lang ito. Okay, and then if it is pure bending, we come up with your flexional stress, wherein your flexional stress is equal to 32m over pi d cubed times the hollow factor. Okay, again, this would be generic. Okay, aatsin lang po are pag siya ay solid. Kapag hollow, you have to indicate. Okay, so tatandaan lang po natin ito pong dalawang equation na ito. Okay, now if we have combined torsion and bending, okay, ano po ang ating gagawin? We have what we call the maximum shear stress theory and the maximum normal stress theory. Okay? So this maximum shear stress theory, ano po ang sinasabi niya? Pag magkasama po yung tension at saka po yung bending, okay? So the material will fail kapag po na-exceed po yung atin na torsion o yung shear stress natin. Kumbaga, dominating po sa kanya would be the shear stress. Okay? And that is being observed if material is ductile. Okay? So this one po is specific for ductile materials. Whereas, kabaliktaran naman po doon sa maximum normal. Okay? This one po is for brittle ones. Ano naman po yung failure niya? So, magkasama po yung torsion and bending, and they observe that the brittle materials, they fail because of the mostly of bending. Okay? So, mostly nasisira siya dahil doon sa bending stress or doon sa normal stress. Kabaliktaran po dito na ang pagkasira niya naman is due to the mainly doon sa shear stress. Okay? Now, for the maximum shear stress, okay, this is the equation for this one. We have tau max is equal to the square root of, okay, tau squared plus sigma over 2 quantity squared. Okay? So, ano po yung para dito sa maximum shear stress? Yun po yung tau max. Okay? At ito naman pong maximum normal would be your sigma maximum. Okay? And what would be the equation for your sigma maximum? That would be sigma over 2 plus your quantity tau squared plus sigma over 2 quantity squared. And if you look at this form po, okay, this seems to be your tau maximum. Okay? Equal to your sigma. Okay? Again, so this equation po, okay, ari po yung maximum shear stress theory. Okay? At ito naman sa maximum normal stress po, ito po yun. It's either ito o kapro. Okay? Again, so this would be used if material is ductile, and then this two naman po if material is brittle. Okay? So yan po yung gagamitin natin. Now, let us derive now the equation. So let us now derive the equation for tau max and sigma maximum. Okay? So ano po ang gagawin natin? For tau here, ilalagay po natin dito yung equation para sa torsion. Okay? And dun sa sigma po, ilalagay natin yung equation para sa bending. Nasundan po ba yung sinabi ko? Hello? Hello? Nakuha? Naintindihan po?
Yes po.
Okay, so babalikan natin yung equation ha. O dito ka lang muna ilagay. So let us have here the maximum shear stress. Aring po ay para sa ductile. Okay? So, tau max is equal to square root of tau squared plus sigma over 2 quantity squared. Okay? So, palitan po natin yung tau at saka yung sigma. Okay? So, this would be yung tau 16t over pi d cubed times 1 over 1 minus k to the 4th. Okay, yan po yun. And then, squared po natin. Plus, yung pong sigma. Ano po yung sigma equation? 32m over pi d cubed times the hollow factor, 1 over 1 minus k to the 4th divided by 2 and then squared. And then you take the square. Okay? Naintindihan? You look at this now. Okay? You simplify. If you are to simplify this, okay, this would become, ayan, 16t over pi d cubed, okay, squared times 1 over 1 minus k to the 4th squared plus, nasusunod pa po ba? This is 32 over 2. That will yield 16 also. 16m over pi d cubed squared times 1 over 1 minus k to the 4th squared. Okay? Yan. And then here, you could see that there are perfect squares. Okay? There are perfect squares. And with these two po, meron po tayong common. Ano yung common between these two terms? Dito at saka doon. Alin po yung common term dyan? Ito pong 1 over 1 minus k to the fourth squared. Tama po ba? Meron din yan dito sa kabila. Okay? And then at the same time, yung pong 16 over pi d cube. Okay? Ito po, common din po yan dito sa kabila. Okay? Nasundan po ba ako? Hello? Naintindihan?
Yes po.
And these are
Yes
also perfect squares. These are also perfect squares. So, pwede po natin ilabas ng square root sign. Okay? So, ilabas po natin ng square root sign. We have 16 over pi d cube. Okay? So, kung ilalabas po natin siya ng atin na square root sign, so maaalis na po yung 2. Okay? So, yan na po yun. And then, ano pa yung common? 1 over 1 minus k to the fourth, our hollow factor. Okay? What is left now, doon po sa atin na radical sign. Ano na lang po ang natira? Ari po na ilabas na natin. Okay? Yan. And then square. Okay? Same thing with this one. Ganon din po dito. So, ano na lang kung natira dito? It would simply be t squared plus m squared. Okay, that this is t squared plus m squared na lang. Kasi ari po, nilabas na din po natin doon sa atin na radical sign. Okay? So, this term po, okay, yung square root of t squared plus m squared, this is considered as your TE. Ang tawag po natin dyan is the equivalent twisting moment. Okay? This is equivalent twisting moment. Okay? And what do you say now doon sa ating final equation? So, kung ari po ay TE, pwedeng sabihin natin that your tau maximum would be equal to 16. You have here TE over pi d cube times 1 over 1 minus k to the fourth. Okay? So, ito po yung ating tau maximum. Okay? Para ano po masasabi natin? Parehas lang din siya ng equation na torsion. Di ba? So, torsion natin is 16t over pi d cube. And since this is combined, ang gagamitin natin is TE, which is, yung TE po natin is equal to square root of t squared plus m squared. Naintindihan? And what would you do with this is, this tau maximum, okay, is to be equated to your tau d. Okay, so tau d to be equated to your tau maximum. This is for a good design, and you come up with the required dimension. Okay, so tau d should be equal to tau maximum, which is 16 TE over pi d cube times 1 over 1 minus k to the fourth. Kung solid po yun, aalsin po ulit ito. Okay, hindi po ulit yun isasama. Kung siya po ay hollow, so included po yun. Okay? Now, what about the value of tau d? Ano po ang gagamitin natin doon sa tau d? Again, this can be tau u over fs or tau y over the factor of safety, dependent upon the basis of design. Although this is for ducting po, okay, pwede din po natin gamitin yung tau u over fs kung yun po yung minention as the basis of design. Maliwanag po ba? Hello? Hello? Nakuha po ba? Naintindihan po? Okay, good. So, katulad lang din for
Yes,
siya,
po, ma'am.
para po madali pong maintindihan natin, although this is combined torsion and bending, you look at the equation that is the same lang din ang form doon sa atin na pure torsion. Okay? Instead of T lang po, gagamitin po natin ay TE dahil siya ay combined. Okay? Yan. So, let us have now naman po, okay, yun para naman po sa sigma maximum, okay? So, sigma maximum is sigma over 2 plus tau maximum, okay? So, ganun po ulit ang gagawin natin. Atin po na isa-substitute. So, what is sigma over 2? Okay, so yung sigma over 2 po, dito ko na lang po iladagdag ha. This is maximum normal. Sorry. This is maximum normal. Okay, so sigma max is sigma over 2 plus the square root of this, which is equivalent to tau max. Okay? So let us now substitute. Yung sigma po natin is 32m over pi d cubed times 1 over 1 minus k to the 4th. And then divide this by 2 para po doon. Okay? Plus, ano nga yung nakuha nating tau max kanina? Ito po yun. 16 TE. 16 TE over pi d cubed times 1 over 1 minus k to the 4th. Okay, yan. Okay? So, yan po ngayon yung magiging equation natin. So, ang gagawin naman po natin, igagaya naman po natin siya doon sa form ng pure bending. Okay? Ano po yung equation ng ating sa pure bending? 32m over pi d cubed. So, ang ating po gagawin, ang ilalabas po natin would be 32 over pi d cubed times 1 over 1 minus k to the 4th. Okay? Yun po yung common dito sa dalawa. Okay? Yan. So, ito po common. So, inilabas po natin. Okay? Tapos, 32 over pi d cubed. Yan. So, ano po ang resulting value dito? Kung nilabas po natin yung 32 over pi d cubed, ang matitira po would be 1 half. Okay? Diba? 1 na lang dito over 2. So, 1 half po. Okay? 1 half of m. Okay? 1 half of m. Okay? Plus, ano naman po dito? This is only 16 and this is 32. So, ibig sabihin, this is 1 half of TE. Okay? Kasi 1 half, 32 divided by 2 will yield 16. Nakuha? So, 1 half of M plus 1 half of TE. Common pa rin po din yung 1 half. So, this can be 32 over pi d cubed times 1 over 1 minus k to the 4th. And then this one is 1 half m plus t. Yan. Okay? So this naman po, right, 1 half of quantity m plus te, ang equivalent po naman yan is me. Okay? Ang me is equivalent bending moment. Okay? This is called the equivalent bending moment. Yan. Okay? Kung kanina, yung te, you call that the equivalent twisting moment. Ito naman po is equivalent bending moment, ME. So, what would be the final form of your sigma maximum? Okay? So, anong final form? 32 over pi d cubed times this, at ito po, lahat ay ME. Okay? So, kung sulatin po natin yun, okay, so the final form of your sigma maximum would be equal to 32 ME over pi d cubed times the hollow factor 1 over 1 minus k to the 4th. Kung hollow, kasama to. Kung siya po ay solid, aalsin po ito. Okay? Again, ano po yung ME natin? Ano po ang value ng ME? This is the equivalent bending moment equal to 1 half of M plus T. Okay? Yan po yung value. Okay? And ano po gagawin? This sigma max and this tau max, these are your induced stresses. Kaya anong ginawa natin dito? We equate the design stress to the induced stress. So, ganun din po dito. Okay? For a good design, you need to equate, you need to equate design stress to the induced stress, which is your sigma maximum. Okay? For the design stress here, sigma D, this will be sigma U over factor of safety, since this is what? This is good for brittle material. Okay? Brittle. So, may question po ba tayo? Hello? Hello? Masusundan pa ba? Naririnig pa po?
Yes po, ma'am.
So, ano man po pansin po natin? The same equations lang po. Ngayon lang po atin na ginawa na siya combine. Okay? Instead of T and M, we are using now TE and FE, the equivalent twisting moment and the equivalent bending moment. Okay, just take note of the equations, okay, for TE and FE. For TE, that would be square root of T squared plus M squared. Okay, and for FE, it will be 1/2 times the quantity M plus D. Okay, question? Hello? Wala po. Okay? So, since ano na lang, 5 minutes na lang tayo, okay? You go back, okay? You go back doon sa kanina natin na sample, okay? Then this, you try this sample too. This one po, hindi na po natin i-consider ang bending effect only. Okay? Kaya po naging pure bending to kanina kasi nakalagay po dito, consider bending effect only. So, isasama na po natin dito yung torsional effect. So, it will now be a combination of torsion and bending. Okay? So, torsion will come from the power and yung bending naman po galing doon sa sparking. Okay? So, using this, for example po, ano po ang gagamitin natin equation dyan? Is it the maximum normal stress or the maximum shear stress theory? Alin po sa dalawa ang gagamitin? Hello? Alin po sa dalawa ang gagamitin? Yung maximum shear stress or yung maximum normal stress theory? Answer po.
Maximum shear stress theory po.
Okay, so it would be the maximum shear stress theory. Bakit po yun yung gagamitin? Kasi this one is a ductile material. Okay, ganun lang po ang pagpili. Maximum shear stress, maximum normal stress. Paano po ipipiliin? Depende sa type ng material, whether ductile or rigid. Okay? Okay, so nakita po natin, combine po siya ng torsion tsaka ng bending. Kaya yun pong dalawa yung pagpipilihan natin. Okay? Maliwanag po. So, you try solving po this problem too, okay? Considering combined torsion at bending. Subject for our subject po sa ating ulit na discussion by our next meeting. Okay? May question pa po sila. Nakapin po ba, Are? Kanina? Nakapin niyo po ba yung derivation? You can take a screenshot of it. Pero baka nilagay dito. Okay. So, you can take a screenshot of this now para tell me if it's done na po. Para makita niyo po yung derivation. Pakiano nyo na lang po sa akin para ililipat ko kung tapos na po kayo i-screenshot. Or kung natandaan nyo naman po, you can derive it on your own.
So here, in the idea that R
Hello?
Okay na po.
Okay na po. So, I'll turn to the other page. Yan.
Water cup. Your cup. Okay na rin po.
Okay na? Okay. Sige. Okay. Thank you. Bye.
Thank you po, ma'am.
Thank you po.
Thank you po.
So, you try to solve po ha yung problem 2. Considering combined na po yung dalawa. Bye-bye.
Thank you po.